the robotics community is. I'm sure you all know. In Austin has been around for a while, but really starting to kind of pick up. I think, as Usman said, UT really growing as a school, focusing a lot more on robotics, has drove a lot to that. I myself recently went from kind of external recruiting to join a startup in Austin called Skyways, where we are doing UAV cargo delivery. So we are building those planes, building the software, doing everything in Austin. So, kind of hopefully another good landmark of companies looking at Austin as a great place to grow their robotics talents. This meeting will be recorded and you will be able to watch it afterwards on YouTube. And we're going to have Usman and Yunzhe do a demo for us, which we love. Yeah, it's kind of, all of our, I think, favorite parts is to actually see the robots in action. So excited to see that. And after the presentation, we'll have a little Q&A. So please feel free to stick around, ask any questions, and just kind of network with the community here. But yeah, thanks everybody, and Usman, it's now all yours.
All right, sounds good. I'm very excited to be here, and thanks to Florent for inviting me. What I'm going to do is that I'm going to go to our laundry room where the robot is set up, and I'll take out some clothes from the dryer. And we'll see the robot fold it. Hopefully it'll succeed, and there won't be any problem. So let me just quickly take this off here and just close this for a second. I'm just gonna walk to the other room, plug it back in. All right, okay. So this is our so this is my laundry room, and we've set up the robot here in the laundry room. These are the two robot arms, and so that's the laundry folding table. So that's my dryer, and I'm going to basically just go here and take out some clothes from the dryer here. I'm just gonna grab these. Okay, and I'm just gonna throw them in here. Okay, so no sorting, nothing. Okay, you just put them out, right? I mean, this, you shouldn't have to sort your clothes, right? I mean, if you're sorting and doing stuff, then that defeats the purpose. So, right, let's go. Let's do that here. Let's start with the blue one, I guess. Okay, so that's the. I'm gonna turn on this robot here, and. So I'm trying to see if I can hold it and do it at the same time, which is a little hard. Maybe what I can do is just put this over here. Let's see here. I'm just going to put this in here, maybe that you can see me, the robot. So I'm just going to lift this here. Just initialize the robot here. Just turn it on and put it in a initial state. There we go. Do the same for this one here. And okay, that's the robot set up here. And all right, so that's the software I have. So this is a Intel Core i7 machine with a RTX 5060, 8 gig RAM. That's our software. It says welcome to laundry folding software. What's I don't know what that is. All right, okay. So we initialize, we start the program. So this is the software sort of that we're making that is sold with the robot. So for example, this setup here, these robot arms at the table, that and everything is basic, and the software itself is a one time of, I think, of 3,000, all of this. And then this is going to be $20 a month subscription fee. So the first step is to the top. You can see are what things should look like, and the bottom is what the cameras are. So we want the port this one to be, we can change the, just select the port and then it just selects a different camera. So this one should be the top one, and then the left arm and the right arm. So click next here. And I'm going to test the arms, make sure the ports are right. So I'm going to click on view, verify right arm, and okay, verify right arm. It's not. I think I might have to maybe start. I'm just going to restart the software. It's possible. Yeah. I think I think I started the software before I um, plugged it in. So so you wanna plug it in and then start the software. So all right, okay. So it's initializing once again. What is this thing that keeps showing up? Okay, so we're just gonna wait here. Acer Quick Panel. Okay, we definitely don't need that. Okay, so so again, we're gonna skip these steps here. I'm gonna verify the right arm, and you can see the right arm is moving. That's great. I'm going to verify the left arm. Yes, the left arm moves there. It's nice. All right, so all of that is good. This is some calibration. You can see that the top needs to look like this, and you can see that it is like that. You know, the bottom, so we've got some boundaries. Things need to be in those boundaries, and it's looking good. And then the left camera, this is how it should look like on the left, and this is how it is right now. So if I put my arm here, you can see that's me. Yeah, so that's good. And then the right one is also calibrated. That's my arm over there. That's calibrated too. So this is some initial calibration. We're all good, and that's it. Now we're ready. So I'm just gonna click start, and now I'm clicking start, and then it's gonna start grabbing clothes and folding them. Now we have it there. It's gonna try to make it flat, and after that, it's gonna fold it. So. And some t-shirts can be a little easier than others. Some but most it does pretty fast, I think. Um, Now this model that you're looking at was trained on 100 different t-shirts, but none of these were seen before. These are all unseen. So this is all unseen data. But this is kind of like a thick nylon type t-shirt. I think it's nylon polyester mix, not pure cotton. Cotton, I think, tends to be a little easier. So, did something go wrong there? That sound it made. Yeah. No. Let's keep watching here.
Yeah, I'm getting goosebumps just by seeing what he's doing until now. It's really amazing.
What's that, sorry?
I'm getting goosebumps just by watching what he's been doing so far. It's like, this is amazing.
I think it's almost done here. It's done with this one. I think so, yeah. Now, let me take this out. Yep, I think it's going to fold it now. It's ready for folding. And now it's going to be this folding, and it's going to throw them in this box here. Okay, so it's going to keep stacking them in here one after the other. So that was one fold. Fold it once, and then it's going to do a second one. This t-shirt can get a bit thick. The material is a little thicker, so it becomes a bit challenging stacking it. That's it. It's done. Now it's gonna grab it here. And it's gonna comes here and just kind of like goes down and just okay. So we drop that over there. And thanks, Gord. Now it's gonna do the next one. I hope it does the white one, because that would be nice. Okay, there we go. It's doing the white one. This shouldn't be hard. This is mostly cotton. So so I mean, you probably have a lot of questions. What happens if he grabs more than one, right? I mean, maybe he'll do that. I don't know. I mean, it might do it. If they're too crumpled, it happens. Sometimes it'll grab like four, and then it'll put all the others back. So, I'm gonna start working on this one here now. So, all right. And you can see in the software there's not much happening here. It's just basically just showing the camera views. That's it.
So is it like 3 cameras or like the
Three
arm?
cameras. Yep. There's this one here,
Okay.
and then there's two on the arm. So I think it's almost done with this one here. Let's see here. Yep, I think so. Oh yeah, that opened up there. So let's see what happens next. I think it should be done with this one. So oh yeah, okay, it's gonna be done very soon now. Oh no, okay, maybe not. Take much longer. Okay, let's see what it does now. Okay, now it still wants to go with that. All right. And so this lighting is important. There's these lights on top, and then that light over there. So it needs light to see. I guess that part is very important. And mostly white light, just plain white light. Okay. Let's see what is it doing here. Okay, so that got a bit stuck there. It's waiting for it to let go. Sometimes slightly weird things happen. Okay, I mean, it didn't want to let go. It just likes to t-shirt way too much. So I'm just grabbing on with that. I think it should be done with this one pretty soon. Enough. It's laid it down enough times. So hopefully I'm okay. There we go. Hopefully it's not getting bothered by me talking or standing on it. You know how you stand on somebody and then they can't do it properly. So okay, there we go. Nice. All right, very nice. And it's gonna do this once more, and then there we go. Nice. There we go. All right, there we go. Okay. Time to fold it and stack it. Right. You see the robot arms. I mean, it's got these servos here, big ones here. Because that's and then as you go towards the end, the servos get smaller because you don't need these need to be strong, right?
Yep.
There we go. All right. That's the second fold. It's folding it twice there. I'm only doing on battery 8%. Okay, good. Okay, well, this is a nice fold. There you go. Okay, nicely folded as you can see. With that, now it's gonna pick it up there, and it's gonna stack it on top. Once it's done, they're all stacked, and you can just put them in the drawer. There we go. So it's gonna pick them. There we go. That's nice. Look at that. It's two over here. Okay, now let's look at this one. Okay, here we go. It's time for the multi. Is it gonna do multicolored? Oh no. I hope this one. I was hoping it would get this one. But I guess let's see what happens with the multicolors. It can be slightly confusion. Remember, there's nothing like this in the training data. There's no multicolor T-shirt in the training data. There's nothing like this. This is a T-shirt my daughter got from I don't know where. And I remember when I was her age, I used to wear T-shirts like this too. So, oh, okay, got lucky. There we go. Got lucky. Okay, maybe it's gonna do it now. Oh, okay. I think we got lucky with this one. Okay, that happens sometimes, right? Okay, one fold. I think it's gonna fold it again. It wants to make it nice and flat before folding it. And God, it's gonna do that much nose. Yeah. Okay. Right, I think it should be ready to fold them now.
Wow, that move was amazing.
Yeah, it was. I just got lucky, I think, with this one. And
Yeah, but it's like the fact that actually, yeah,
but that's what happens when you put the clothes in a crumple. Anything can happen.
yeah,
This could
like
go either way. Nobody knows.
like
So
you have this like subtle like moves that the humans do. It's amazing.
and now it's doing the other one here. It's doing the final fold two, and it's gonna stack that. So I don't know how long we've been running. Maybe I think it's averaging pretty good. I think it's averaging at about 2 minutes per t-shirt. Maybe not much longer. So this
Mhm.
time is very important. We wanted to make it even faster, and we're working on that. But for now, at least it's at about 2 minutes 20 seconds. So we go. Grabbing that and trying to place it into the stack pile.
Nice.
See it right there. Okay, going for the next one. And this will be the last one. I'll just stop it after this, okay? So that we can take a look at Yunzhe then also.
Sounds
So
good.
here we go. We're gonna do. Let's see what it does with two. Let's see what it. Okay, it's gonna grab that one only. Okay, all right. Okay, no. Okay, no multiple. Okay. As you can see, it's very careful in grabbing. You can see it's careful enough not to grab multiple. But that can happen. It could happen, and then corrects itself if that happens. So, all right. I think that's what that's here. Um, this one. So it did. You can see it did a collared T-shirt, then a plain one, and then a multicolored one. And here we go. It's almost done with this one too. I'm gonna stop it after this, and we can look at the quality of the foam.
Sounds good.
That's it. We're done with this too. And then here we go. So I mean, what you run this, and then you just leave the room and you go away. And by the time you come back, all the clothes are gonna be folded and stacked right there.
Yeah, that's so
So,
cool.
okay, there we go. It's folding that. And we've been doing that. That's how I test it. I run it and I just go when I come back after half an hour. I give it maybe 10 clothes or something. I mean, we're still remember this was trained only with 100 t-shirts, and we're adding more, and more is going to make it more accurate, better. The fold quality will get better. So, so there's a subscription model because we're going to be updating it, the software. We're going to be updating it every 2 weeks. So once you have this running in your home every 2 weeks, there's a new model that comes, which is going to be faster, more accurate. Okay, here we go. The last one, I'm going to stop it up. This was okay. This was okay. All right, not too good. All right, let's stop the software here. All right, stop, and it's time to stop. So let's take a look here. Right, so let's see our first one here. And so that's how it folded. That was the first one here. We can kind of get in here. And this one, of course, was very nice here. This one here. This one got a bit messed up, but whatever. It's okay. I mean, I've done worse myself, so I don't mind.
Yeah, this is amazing. Like, yeah, seeing robots doing this, like, I mean, this hasn't been possible until recently. So it's just,
Yeah.
I can't contain my excitement.
Well, yeah. I mean, I think we also get excited. When I'm watching it, I get excited every time.
Yeah.
Yeah.
Amazing.
Yeah. Thanks. Yeah. I mean,
Yeah, don't forget
and
to put your website name, website address on the chat so other people can, like, if you have a website for this.
oh yeah, I'll put the company website on the chat so you can sign up on the waiting list. We have a waiting list going on, and I'll also hand over to Yunza, and he can do a short demo on the Nano, and he can also show us the Nano, the size. Like this is a $1,000 laptop. This one here, but he has his the Nano is for 250 if you get it from China. If you get it from Amazon in the US, it's 400. But if you buy it from China through Alibaba or something, it's 250 actually. So
yeah, I bought, mine was like almost $500, $600. I buy it from eBay. My Jetson Nano. So
yeah, I've seen some of those eBay prices. They're very high. I'm trying to look for the chat box here. Let's see. What am I missing? In call on the go chat. Where's chat gonna be? Why can't I see chat?
Yeah, I don't know on mobile, but
It's fine. I'm gonna now that I'm done here, I'm gonna move to the other room, and because on the computer I can access all the options very nicely. And let me put that there. Yunza, do you want to? Would you like to take over, Yunza?
Sure. Thank you, Usman. Um, so this is the environment for all the model debug and training. And you can see those two arms are used before to record an action and train the models. And this is just another we bought recently because we want to sell the everything to customer as cheap as possible. So we try to move everything onto this small Just Nano. The only difference is system is a Ubuntu system, come with Just Nano, and we try to make it more friendly to general people. And the interface are almost the same as before. I already set up everything, so we can just start. Um, so I prepare several shirts there, and now I can.
I'm sorry, Yunza. I was muted. I was gonna say, can we see the nano quickly, Yunza?
Sure, let me put it into the box first.
Oh, okay. Sorry. Don't mind, let me interrupt you. I'm sorry.
And this is just nano. It has some display port. In the future, in the final products, we will prepare a small screen for the user, and it would be a touch screen probably, so they don't need the keyboard and the mouse to do it. And it need all the ports for the from the robot arm and the camera, especially the top camera.
What we can do is mainly connect a small like a touchscreen device. You can get it for $50 from Amazon. Just connect that, and that's gonna basically be the interface for the robot. Just touchscreen, start, stop, and everything. Sorry, go ahead.
Okay, I just start the program. Maybe I can show if it picks multiple shirts, what would happen.
It's up
I
to
can
you.
manually put the clothes there.
It's up to you. Go ahead. Go ahead. Yeah. I already showed the folding, so you can show something different if you'd like. Yeah.
Yeah, I would like to show something different.
I'm just gonna post the URL of the website and chat. I'm able to do it now, and over there, there's the sign up form over there. So
So maybe I can do the multiple shirts next time.
next time, okay, and then that's fast. It's wow, okay, that white shirt was very fast. Okay.
So as Usman said, whenever it's flattened and accepted by the robot, it will start the folding. Folding is fast. Action is easy.
Yeah, there was a gentleman who was telling us, you should get one of those folding machines, those folding for clothes that you get it from. And then he looked at our video. He's like, you know what, just forget it. Your robot folds nicer. Just use your robot folding. So, but yeah,
yeah, the market is
we
very
actually
large.
tried that. We tried that actually. We tried it on that thing, and it was kind of difficult for the robot.
Here.
Multiple shirts, in no?
Yeah, sure. Let me see how many it will pick.
But
I
let's see.
think it
Yeah,
will pick this one. I will put the red one there also.
it's very careful in picking. Like it doesn't. It
Put it here.
usually doesn't pick multiple. Um, okay, there we go. So, okay, it's going to put that one back. Okay, so that one's gone back already. So put the yellow one back, and it's going to go with the red one now.
Now the clothes are fully crumpled.
Yeah, that was yeah. No. It's not hard to figure out.
So the most of the time I spend on the flattened shares. That's the most challenging part of this task.
And I think that things like doing like, hotel towels, I mean, Yunza and I have discussed this. I think it's going to be easier because there's less variation in them, right? I
Yeah,
mean,
this like
T-shirts
yeah,
have different designs, colors, logos, sizes. I mean, towels have sizes too, but there's not much variation. I mean, there's small, medium, and large, pretty much. Oh, that okay. That looks like it did that pretty fast. Okay.
Let me test one more thing after this done. I just put the clothes on the table to see if it knows there is a clothes there. So it will not pick another clothes from the box. It needed to know it need to finish the current job and then start the next one.
It's your demo. Go ahead. So. Okay, that's nice. Nice. All right. I think we were also discussing, Florian, doing underwear. I think that's going to be easier because typically people don't fold underwear.
Yeah.
We're just going to put that in a separate box. So just like there's a box for the t-shirts, we're going to stack the pants in the same box, and then we'll just put the underwear in a small underwear box, or socks also there. That's probably that'll probably be the easiest part, I think.
Yeah, there's not a lot of variation as far as like folding, right? So yeah.
Yep. There's
Yeah, pretty cool. For me, it's like I can't stop watching this.
Yeah, it's kind of fun to watch it. I sometimes I go back and I watch the videos, and I'm just kind of sitting and watching them, and I'm like, oh, okay, that's nice. I'm getting a nice feeling watching it.
Let me put the clothes there.
You just threw a shirt there. Okay. Oh yeah.
I mean, what
Okay.
hotel industry can be like a pretty big market for this. That's kind of what I'm thinking. Is like this could be amazing. Like there's so many towels in hotels every day that somebody has to fold.
Well, I can tell you that I get a feel for it at home. I mean, while I'm testing, I just like I showed you right now, I took the clothes out of the dryer. That's what you take the clothes out of the dryer, put in the box, and you just come and, I don't know, go do what you want to do, and come back after half an hour, and they're stacked and folded.
Yeah.
And it's just like you're doing laundry. When you put the clothes in the laundry machine, and you don't think about it, you just come back after 45 minutes when the laundry is done. So it's the exact same thing. But we're excited about adding other tasks, but I think for now it's one at a time. So just the laundry folding, just getting that done for now, and now this, as you can see, mine was on the 1K laptop, and this one is on a Nano. So that's so it's gonna be in like we're gonna just put a box around it, as Yunza was mentioning earlier.
Yeah.
So
maybe we can stop here.
Okay. All right. Yeah, we could keep going all night, or I think.
Yeah, I think so.
Yeah. Yeah, this is amazing. Yeah, so
So we focus on the repeatability and the success rate. So currently the success rate is 100% for every shirt. That's what we want. We don't want the user go and come back and see it stuck on one shirt and still a lot of shirts in the box.
Right. That's very important. Right. This auto fault recovery, and also collision avoidance. That's another thing with two arms. The last thing you want is them to be hitting you, or hitting another person standing nearby is kind of looking. We don't want to hit people either. So that's one reason why the movements are also a little. Some people have said make it faster. I'm like, we could make it faster, but we don't want to end up getting sued by people. Your robot arm hit us. We went to the hospital. Now I mean, we don't want that. So the safety is important.
So you're gonna like do some kind of collision avoidance where you're gonna look. Like, let's say there's a kid shows up or something like that, where you can maybe if somebody is that's too close, or you're thinking something like that. Like really.
Well, I mean, it's one way to do is to ensure that it doesn't leave. It's not like turning around and it's working on the table mainly. Yeah. We don't want to turn around and start doing stuff here and there randomly. I mean, so you can. That's not too hard to enforce. There's that. But I mean, there's probably we're going to add to it that if it sees, if a human shows up on the table, then we can just make it, just stop completely. Just, okay, halt. We see something. Right now you can see I was putting my hand and stuff, but it doesn't affect it right now. So, but I think the movements also are not sudden, they're smooth, and that also goes to safety, right? I mean, if it's not moving, but at the same time, it's a strong arm. I'll tell you this much. I mean, these servos are, can be, they have their, once they decide to move this much, they're going to move that much,
Yeah, maybe you have to have like another camera just for the safety or something like that.
Right. Yeah. We can probably also, we can just do it with the same cam. It's just a feature we want to add. So yeah, I see some questions here now. Entire learning process was that the robot wants to. That's right, Robert. Yeah, it's machine learning. So it's a learning based. Yeah, I mean, there's no algorithm, unfortunately, to train a robot to do stuff. So we have to resort to machine learning. But yes, that's right. John, I'm seeing a question. It's pretty much what Robert said, was based mainly. It's showing it videos. So so that's how we train it.
Okay, thank you.
Yeah. Like, can you maybe, I don't know, you don't have to release too much of the information, but like how big of like for training, like how long did it take for like training? Like, it took like days or weeks to train it? And I don't know if you can talk about like the kind of the hardware that you use for the training as well.
Yeah. It's trained on RTX 4090. It's just me and Yunzhe. We're making this in our home. So there's it's basically secondhand desktops from eBay that we bought. And they're pretty good. I have to tell you, they're not bad. I mean, if you buy a refurbished Dell desktop, they actually come with with warranty. So it's better than paying full price, I think. I mean, so yeah, I mean, yeah, we trained it on that, and that's actually a very good question, and that's a very important point, because I mean, Yunzhe and I have done other work, and we basically I always thought that you need clusters and big machines, and I think some of these commercial consumer grade GPUs, I mean, hands off to NVIDIA for making them accessible to people like us, and trying to keep the price low. I mean, I think, I mean, you've seen, I mean, if you compare the price of 800, right, or 800 versus RTX, it's a huge difference. So some people say even RTX is too much. I'm like, well, you should look at the price of 800 or A100. Yet, yeah, it's trained on that, and yeah, it's it's yeah, we made it. We trained it on those machines. The time you're saying it can take a bit of time. That's true. It can take a bit of time, because it is an RTX 4090, and because of the limited RAM size, we can't go with the large batch size, right? So batch size is limited, but like, what's the memory of 800? I don't know, like it goes up to pretty large memories, like 32, 64 gig RAM. But I think RTX has maximum of 24. So so you're limited there.
Yeah, RTX
so that
really has like 24 gigs.
That's the maximum it has. Yeah, the RTX 4090. That's the desktop version. Laptop has even less.
Yeah.
So,
cool.
So yeah.
Can you talk a little bit about like what it took to shrink the model? I don't know if you had to shrink the model to make it work on a Jetson Nano. Like, do you have to do anything special for that, or just move the same model from what you have on the laptop to a Jetson Nano?
But we had to. I mean, we had to make some slight adjustments. Yeah, we had to make adjustments. So I think some questions are being asked that are related to the model. So it's yeah, I mean, Nihal, mainly single model, I would say. Yeah, mainly it's end to end we're doing, um, um, yep, and so Robert Perfetti should be able to learn more completely with sleeves folded back. Yeah, I mean, well, we hope so. I mean, we are going to do long sleeve also, and yeah, I mean, one challenge is with the hardware, right? I mean, the hardware are the grippers, and there's not much, but at the same time, quite a bit that we can do with those. So yeah, there's some limitation with the hardware. So, but there's a trade-off, I mean, if we get other hardware, it's going to cost more, and we don't know if it's going to work. I mean, we don't know, um, if the model is going to work on Nano. So there are various trade-offs, but it's a constant work in process. It could work. We don't know until we have the hardware and we try to make it work. But yeah, that's a good point, Robert. I mean, I think before long sleeve, we're probably gonna do just underwear, socks, and pants. So at least you've got a full set of things. I mean, I think almost everyone in this meeting is wearing a t-shirt, collar or no collar. So, and it can do both collar and no collar, but it needs to do pants because pants are there, and then socks are. These are like the basic fundamental things that everyone wears daily: a t-shirt, pant, underwear, socks. So, but how would you teach it and using human videos? No, I'm not saying you would add a third arm. No, I'm just no. I'm I'm just saying that we are basically um, yeah, we would it's teaching learning with two arms. I'm just saying by additional hardware I mean maybe hands kind of things instead of grippers. That's what I mean. Yeah. It's weird, hands are still priced high, so yeah, we have to see what happens. We have to see. But yeah. And Raul, you asked a question. Well, I mean, I can't go too many details into our data set, but yeah, it's our data set. I can say it's our data set. So,
Sure, the light variation like influences like what it can do. It's like because when I train my robot, I have like 4 lights, and when I train it, I forgot which lights I turn on. So when I went back and tried to do the work, it's like, oh, which light did I turn? This light and this light, this light. So I forget which lights I had on, and then sometimes it works, sometimes it didn't. So I wonder how much light has a say there. Like, let's say, I mean, usually when you're in a room, you only have one light that you turn on, but I
yeah.
kind of want.
I mean, the lighting here is basically, as long as I usually show this to people. I mean, it's just, it's just standard LED white bulbs, and that's pretty much it. As I mean, as long as you've got you've got standard white light, it's fine. We've tested it in at least 3 different places with the same white light, and but that's a very good point you've raised. I mean, these things can affect it. I think if you change the lighting, I think it will still work. It may not fold some things as well as you'd like, but it will still work. Yeah, but for best optimal performance, just the standard white light will do. So, and yeah, so we're making a list of. So we're basically right now sort of just packaging it into the Nano, and then we're there's the hardware would pretty much ship from the manufacturer in China. It doesn't make sense for us to get it here and then ship it. It's just double shipping cost. And the software, the box, we would ship from here. So, for example, if you say, okay, I want it once So you have the 3K for the robot arms, the table, the wires, the light, everything, and then the software is just a subscription, and that is so the Nano is going to be hopefully included in that 3K price, and then the idea is that to keep making updates to improve it. Even now we're always updating it. So I think there's a question here about physical intelligence. Yeah, that's a good question. I mean, I guess I've seen their work online. I'm not sure what they're planning to do or where they're going with it. So it's unclear to me right now. I mean, we've been very much focused on generalization. And I think as Yunzhe mentioned earlier, generalization and pricing are two very, very important things for us. So, and of course it has to work also. I mean, it has to fold the clothes. So, and I would say speed, fault recovery, and these things are very important. So I think different labs, different companies might have their own priorities of what they want to get out of it or where they're going. So to answer your question, Evelyn, it's unclear to me what their plan is. You're saying there's one small VLA, okay, by HF Hugging Face. Okay, no, I haven't seen that small VLA. I haven't seen that tried that model. So. Oh, right. Okay. The Hugging Face, I've seen the robot. Yes, I've seen the robot.
Yeah, I've been trying this one. I did try the action chunky model. It's worked pretty good on this one. Small VLA, I think that's the one that just came out, and I've been playing with it. But yeah, it's some open source out there that does some work. It's not. It does. I haven't seen anything like this where you can actually do the like folding clothes. This is a level higher than whatever I've seen from open source for sure. So that's why I was like so excited to see it. Yeah, it's amazing.
Yeah, no, thanks. Yeah, I mean, we're basically, we're just focused on the generalization and the accuracy and fault recovery, things like that. I think that I've seen people try to use Pi Zero on arms, and they had some initial experience.
Yeah, I did start with Pi Zero. Well, first of all, Pi Zero doesn't fit on my RTX. I had a hard time fitting it on the RTX 3090. So that was the biggest problem. Like whatever I tried, I could not fit it, like the batch size and all that. So that was yeah. So I think some people figure it out, but you probably have to play with the all the parameters there to figure out how to fit it. But I haven't been able to fit it. So that's why I kind of banned that one. But the small VLA came out. I will need to try it out. That's another cool one that people have had some success. But usually the tasks are relatively small. Like I haven't seen anyone, like I was able, like this robot arm here with the ACT was able to open a drawer, pick up a glue stick and then put it in the drawer and close the drawer. That's kind of all it could do. But it doesn't generalize like at all. Like I forgot which lights I had when I trained it.
Okay.
And then I was like, and then all of a sudden it's like, why doesn't it work? Like I haven't done anything different. It's like, okay, try this light.
Right. No, I hear you. Yeah, I've been there too, for sure. Yeah, I mean, it's yeah. I mean, I think we started out with tasks like that, and with some different algorithms, and definitely being able to pick up a little cup of water and pour it into another vial, and being able to do that from different positions. Even that is not very trivial, so it can be a bit challenging. But yeah, I mean, I think I know that the arm you're holding is basically printed, right?
Yeah,
You can
technically
print it.
it's open source. Yeah, somebody was asking, it's Little Robot. It's called the project.
Yeah.
It does some, I mean, things that again, like that's why I'm getting so excited, because the things that we've seen today, I mean, this is a different level than what the open source has. But like these things that I don't know how many people like realize like what you saw today is like it wasn't even possible like some months ago, right? Like I mean, I've seen some demos from Google and
Yeah.
it's
Yeah.
really like whatever Google shows, it's like you have it there. It's amazing. Yeah. So, I mean, the fact that it can fold close is something that hasn't been like we haven't seen robots do I would say probably even months ago. So, as far as I'm
Yeah.
aware, so it's kind of amazing
Yeah, no,
things.
that's true. That's true. Yeah, yeah. I mean, and we're not just folding, like these are clothes that I showed you. These are my clothes and my daughter's clothes, actual clothes. And the one, and then we went to Joanna Stern's home, right? And we folded her clothes. We don't go to a store and buy new clothes, which are easier to fold because
Yeah.
they're flatter and they're less worn. If you try to fold worn clothes, it's kind of a different thing. Actual real clothes that people wear. So, and I think, that also basically is part of the, it's just focusing on a real environment. I see Evelyn is online for a while. Maybe he wants to ask a question. He turned on his camera. Did you have a question, Evelyn?
Yeah. Hey, Florin. Thanks for the presentation, Usman. I had to do something with my daughter and came in late. But what do you think is maybe midterm, long-term price point where generalization works at home?
I mean, this will work in, well, this will work in any home. So this is available now. It's going to be available for sale, maybe 2 weeks from now. We just want to put the Nano into a box and clean it up a little, and we have to work out a few things with our manufacturer. So so this will be available where you can just pay 3,000 and then it'll be shipped to you, and we will be available for support. And thanks for the applause, guys. We'll be available. Me and Yunzhe, we're hoping that there will be no need for actual in-person installation, that anybody will be able to, like I was when you saw the demo on my side, remember I showing the steps of the software. Those calibration steps should be pretty straightforward, and I think for anyone in this group it should be very much possible, and even for general consumers. So setup should be possible, and if not, we'll be available on Zoom to help. In the worst case, yeah, I guess I'll just fly down to your home and say, okay, what happened? Tell me.
You're gonna be selling this on the Robust AI website. That's where we can expect to see it for sale.
Yeah, it's gonna be on the 7xr.tech site.
Okay.
So that's where it's gonna be, where we're just gonna add a cart, and then the shipping is for the hardware is going to come from China directly from our manufacturer. It doesn't make sense for them to ship to us and then we ship to you. Maybe it might make sense, I don't know. But initially, I think they will just ship it to you directly, and then and they would look exactly like the ones I've showed you, and the ones that Yunzhe has is the same robot. And the software we would ship to you. And software is just it would just be a matter of plugging everything in, turning it on, and basically calibrating the top camera, the two arm cameras, and then clicking start, and it should work. So the first version is going to be doing just t-shirts. I mean, we need a little more time, but we're hoping we can squeeze in underwear with that first release. So do t-shirts and underwear. If I can do pants also in that time, we'll see. We're trying to make it at least do these 4 things before shipping. So let's see. Yes, I can drop that again here. Yeah. So, but yeah, I mean, and yeah, I mean that's gonna be it does, and I mean, in terms of sizes, it does small, medium, and large sizes. So if it's extra large, I think that the table, it can be slightly challenging. It can do extra large. It can do children also. Like, so it can do 8-year-olds. That was the the smallest we've done so far. Would be a small 8-year-old would be 8-year-old boy. So 8-year-old boy would wear what? Maybe sort of a small size, right? I mean, small adult, almost you could say a small adult size. I mean, my daughter mostly wears small. Well, actually, no. She used to wear small. Now she wears medium. Kids these days, they like to dress in overdressed, clothes. So that's her style. So she does wear larger than her size, but still it's very doable. So the idea is that it can do kids, and kids laundry is common, right? I mean, you're doing laundry of kids, and those store clothes need to be folded and put away. So I think that the sorting is going to be helpful. I mean, just sorting, just sorting the underwear from the t-shirts, just putting them in the other box. So that's going to be there. Shipping to allows for QA before going to customers. Production from chat. That's right, Tom. So that's a very good point, Tom. Actually, so we are working with them closely to make sure that they do the QA. But you're right. If it's not happening properly, then we will do it ourselves. That's totally right. You're totally right about that. And that is a very big deal. A very big deal. We've had some challenges there. When you're working with somebody who's literally 12 hours away from you in time, they are 12 hours. They're literally on the opposite side of the planet from us. So and it can be a bit of a challenge. But that's right. We have to see. We'll have to see. We're working that out. I think that hopefully when they see more orders coming in, they will also get on top of the QA. But again, us being the main sellers, the main creators of this product, ultimately it mostly falls upon us to ensure that the QA. So we might just tell them, look, just send it to us, and we're going to send it from here. So that might be an option. But I mean, I don't think that will add significantly to the shipping. I don't think. I mean, yeah. I mean, one thing I've learned is that it's amazing how the shipping in world trade, how developed the shipping industry has become. It's just it's pretty amazing. Yeah, those pictures and videos we see of big ships hauling big containers. I mean, yeah, all of that is true. It's very organized, and they've really mastered shipping between continents and from the east and west. So
Cool. Have you thought about like making the hardware yourself, or like, because as I said, like there's like a big like you think 12 hours difference, and there's some complications there. Yeah. So have you ever thought about that, or?
Well, yeah, I mean, it's something I don't want to go into too much detail right now. I mean, right now I think we're going to work with our manufacturers. So let's see what happens. Let's see what happens. I mean, for sure, we have learned a lot about the hardware too. I mean, I didn't know what a servo was, and now I can give you different servo model names, and then and tell you how to control a server. So yeah, it's very interesting when you go to that low level of the hardware. Which, Florian, you might have gotten some exposure to that by building the robot, right? Because they actually supply the boards also for the servo control, right?
Yeah. So I actually went really deep into building. So when I got started with this one, I had a hard time getting the servos from China because we had this trade war, and got me thinking about it. And I went deeper and deeper from, as I said, like I went from the model, training the model, to actually seeing what does it take to build a robot. So I, for the last 3 weeks, I've been like working. I took apart a bunch of brushless motors because of that. I think, and then kind of like learn a bunch of stuff. So so really, like if you actually even like this tiny server in here, because I open up one of the servers, it has like a little like a board with like microchips on it, and so there's like you have a motor, you have the there's like electronics board where you can actually do like the CAN bus, so you can give you like each motor has its own ID, and then you can.
Right.
So you don't have to use like multiple wires. So you practically chain the motors, and then from a main board from the back, you can go in and control all the
As a
motors.
controller, right?
Yeah, the controller, yeah. But it's kind of amazing, like the even like if you get, let's say, if you get one of those bigger motors. So I'm mainly interested right now in the brushless motors because I want to build them myself. So I'm working right now to figure out the electronics. So because there's like you have a microcontroller MCU that you can go ahead and then use like a USB. Let's say you can use an USB or you can use some other protocols to actually talk to it. And then after the microcontroller, you have a like a controller for the motors, and there's some specialized ones that you can really like buy off the shelf. There's one I found from Germany that does like practically almost everything that you need for the motor itself. And so yes, I've been getting all these board like the how do you call them?
Nice.
Yeah, those boards that you can like you practically put them together and then see what you can build before you build all the like really like everything like in the final format. But there's a lot of
around it.
Yeah, but there's like a lot of stuff that yeah. So yeah, just like I got really deep into actually building the motors myself because I want to solve that problem.
I think that's something that ultimately everybody who gets into robotics, I think, feels that they have to do that. Like Yunzhe and I, when we started, we're like, oh, we don't need to know any of that stuff. We'll just do the AI part. And now I'm just like, no, I don't know everything. We can't do this.
I was gonna do the AI part, and then I was like, oh, but I cannot buy the motors, or there's like these huge tariffs. It's like, okay, what's next? And then I got really deep into that. I was like, I have to learn. If I don't build it myself, at least I know how everything works on that motor. And I think that it's very valuable. So
I mean, for the servos, I think it's going to be pretty tough to beat. I mean, I don't know how. See, I don't even know who makes servos, here in North America. But I know that in China, these servos they're companies that are dedicated just to making the servos. That's all they do, and they've got huge catalogs of servos. So and the servos are so important. They're running the robot, right? The entire movement is governed by the servos. So. I discovered also, just like you, that there's a board and then there are software libraries for controlling them, already. So it's there, it's done already. People have done this, and so I was like, okay, that's interesting. That's how the robot is built, basically. And then there's of course 3D printing.
Yeah, there's even software, hardware and things in software too. There's a brushless motor, DC motor that was made by I think MIT. It's called Cheetah. So they use it for the Cheetah robots. So the hardware is open source, and I think even the software as well that goes into the firmware that goes into it as well. So there's ways to actually get started in that direction, and maybe like you can start starting open source and then modify it, or you can start from like what are the main components. That's what I'm trying to do right now. What are the main components to make the electronics board? What is the software the firmware I have to write in there, and then once I have that part, then I'm gonna 3D print the rest. Of course, like that's for just to make something that works first, and then the thing about machining, that's like way out there. But
no, but seriously, Florian, I would love to stay in touch with you about this. I would love to just know. Yeah, I mean, this is because I mean, the AI is AI, but the robot is what you're doing is what the real robot is. I mean, that's it's hardware. And I'm also indulging that, but again, my hands are so tight. Me and Yunzhe were just always just trying to be working on the model and stuff like that. So, but yeah, no, that would be I mean, I would love to just stay in touch about this progress and with the hardware, because I think the hardware is going to play a very important role here, and especially affordability is very important. But yeah, I think Nihal had a question. You had raised your hand for a while. Nihal, did you have a question? Or...
Oh no, it's not a question, but like I've worked with in one of my previous companies. We were building a robot to make t-shirts. So in that, the biggest problem was finding the pickup point, and in your demo, it was done amazingly. I just wanted to say kudos for that.
Yeah, okay.
And one word of advice that I would give regarding the Jetson Nano systems is if you are deploying the developer kits, don't do that. I've done that and burned myself with it. Like not literally burned, but like after a year, every nano that I had there, the gap of week after each other started like failing. I found out that the capacitors that they use for the developer kits are lower quality than the ones they have for industrial grade or something like that. So just a word of advice from a fellow robotics who's like, if you're going
Thanks,
with this,
yeah.
just keep that in mind. Yeah.
Definitely will. I mean, we are slightly new with the Nano, so but we'll see how it goes. Yeah, no, that's definitely useful to know. Let's see, there's a comment. Evelyn, you as by okay, controlling. Yeah, maybe. Raspberry Pi, right? Yeah, I mean,
is 0 an option at all, or is it?
Yeah, there's an option. Yeah, so yeah, after I bought the controller. There's like a dedicated controller. Well, the reason you want, I mean, you can stack them. Like if you can put them inside like in the end, you have to have like a case that looks like a motor, right? So it has to be in case. So if you have room, maybe you can put like a layer.
Oh, you're talking about those ones, not the ones that just showed on the arm. You're talking about the ones inside the servo.
Yeah, inside the servo. That's what I'm talking about. Yeah.
Because I noticed that I built that little robots open source. I put 2 of those. The what is it, SL0100 something.
Yeah.
The servos come with 1 board, but you gotta throw that away and use the other one that the robot recommends, which is like, why are we like tinkering with these tiny boards? Why are they that different and important? Can you just throw a Pi Zero or something more commodity? I don't know.
Yeah,
I'm just curious.
possible. Yeah, so I did actually. There's an option to use a Pi Zero. Well, yeah, I think we're talking about 2 things. I'm mainly thinking about the actual actuator because that's what in my mind is right now. Like I have the actuator, and the actuator you have to be able to control like the torque and the position and all these things. So there's an option where you can use a Pi Zero to kind of have your like the microcontroller piece, where you can actually send more like smart commands. But then there's a dedicated, I said, there's like a dedicated controller for the actual brushless motors. So you go from the main one to the next one, and then so that one does all these pretty complicated algorithms. The FOC, I forget what it stands for. It's an algorithm where it makes the brushless motor to be like very smooth, and so it does this vector, like switching these vectors. Like think about like you have like a 360. So instead of jumping from let's see, from a quarter of the circle to the other one, it does all these kind of algorithms where I don't know, it kind of flips. It's kind of hard to explain because I haven't figured out all yet, but because I'm just trying to figure out the hardware now. But yeah, so there's like dedicated, like really, like you can put this together and you can get like in the end you can do your own PCB. And that's why I aim to do my own PCB, and then put all those components together. And then once you have that, then you get the next part. And I'm being also looking to see what there's somebody here now. So I'm trying to get him to talk to the meetup. He's actually been he built like a full brushless motor from scratch. So even the board, he created his own board, and he's created the winding. He was working on the winding machine, and he got tired of that. So he's like, oh, does anybody else want it? It's like, yeah, I think I might take one because he's done quite a bit of work there. So But yeah, they're just like fascinating. Like I got so deep into this, like building the actual DC brushless DC motor, because it's a bit different than the servos. But I'm looking for like a little bigger arm. Because I want to make like a robot that goes to, and it's a kind of similar application where it goes and unloads the dishwasher and it puts the dishes on the shelf. So, but I need like I was going to try with this one, and then I realized like the arms are so small, and then the practically you have you have the problem with the buying the motors and all these tariffs and stuff. So in controlling, like if you want to do something later on, controlling the supply. So but yeah. Yeah.
And also, you can get. I've seen that some of the servos, they come with like a little $5 like a board. You're welcome, Anthony. Thanks.
Thank you, Anthony.
That have like a little board, and you attach it to the servo, and that board helps you communicate to the servo, via maybe a Raspberry Pi or M5 stack or something like that.
Yeah.
But Florent, actually, I'm gonna have to, if you don't mind, I think we have to leave. I was supposed to leave several minutes ago, but I'm having too much fun, and I would love to just stay and talk about robots all night, but life calls.
Yeah,
So
definitely. Thank you so much, Usman. Thank you so much, Yunzhe. This was like amazing. And then thank you for
that's
coming.
great. Yeah. Yeah, no,
Yes.
I'm so excited to meet you and the group and to show the demo to you guys. It's definitely great to be part of the community, and I think you're doing a really nice job in the whole group of building this meetup group. Let's make it bigger. I think it can become, it should be the major place of robotics in Austin.
Definitely, yes.
So
yeah, please come again. Let's say maybe
okay.
half a year from now or a year from now, see where you are.
We'll come. Okay, for sure. Yeah. All right.
Thanks so
Okay. Nice meeting everybody. Then we'll be in touch then.